Hey, welcome back. In this video we'll cover EC2 instance types. An EC2 instant type is simply just a description of the kind of hardware resources you'll be using. So for example, a T2.micro instance type comes with 1 gig of memory, low to moderate data transfer rates, and one virtual CPU running on a 2.5 gigahertz Intel Xeon processor, while a C5D.18 extra large instance type, on the other hand, is compute optimized and gives you 72 virtual CPUs on a 3 gigahertz Intel Xeon Platinum 8124 processor with 144 gigs of memory. So you'll use the instance type to figure out what hardware best match your application. How much hardware are you actually getting? How much virtual hardware are you getting? And how many virtual CPUs? How much memory? How much network connections? And that will be determined by the instance type. A virtual CPU is just an arbitrary and kind of mysterious metric used by AWS to describe its computer power, but it's meant to make you think in terms of multiprocessor CPUs on your consumer and server motherboards, where more is generally better, but it's difficult to accurately map a single Amazon virtual CPU against any real-world device. So, I mean, while it, the comparison of the T2 micro to the C5D.18X large, one virtual CPU versus 72 virtual CPUs, obviously you should expect a lot more performance out of the C5D compared to the T2 micro. But will it actually give you the exact same performance as a similar physical server out in the real world, where you got 72 CPUs, or cores? That it's not going to be a one-for-one kind of comparison is what they're getting at, but you'll get a good idea based on the number of virtual CPUs that instance type gives. You can compare them between each other based on how many virtual CPUs or how much memory one over the other contains. But there are different families. While in general, the more virtual CPUs and memory you get, the better your instance performs, it's not the whole story. EC2 offers instant type families that are optimized for very different computing tasks. So the T2s, T3s, and M5 instant types are included in the general purpose family because of their ability to perform well for a wide range of uses. But besides the general purpose, we also, AWS has the compute optimized, the memory optimized, the accelerated computing, and storage optimized families of instance types. And so depending on your use case, you may want to select one over the other. Whereas like a C5 and M5 may be kind of compatible processor memory wise to some extent. It might be heavier on the virtual CPUs versus memory in the C5 versus the M5 versus the R5, where it will have more memory versus the CPUs. And the R5 would be better for more memory optimized workloads. Sorry. So we have the basic 5 families, and then the The T's are burstable. We'll get into that a little bit more later too, but they run out of usage. They have an extra level of usage that you can burst to. But when you run out of that, it's like hitting a brick wall, and they really will slow down if you go over your burst limit. So dedicated instance or dedicated host, right? So if regulatory restrictions or company policy requires you to use only physical isolated instances, so that no one else no other company can be on your the physical host, you can either request a dedicated instance or a dedicated host. What's the difference? A dedicated instance is a regular EC2 instance that, instead of sharing a physical host with other AWS customers, runs on an isolated host that is set aside exclusively for your account. A dedicated host also gives you the instance isolation, but in addition allows a higher level of control of how your instances will be placed and run within the host environment. Dedicated hosts can also simplify and reduce the cost of running licensed software. Both levels involve extra per hour pricing and are available using on-demand, reserved, or spot, which we'll discuss a little bit later in the chapter on pricing. But for a dedicated host, you technically own the whole host, and your instances will always run on the same physical host. You can run as many instances as possible on your dedicated host, up to the physical limit of total CPUs and memory. If you stop and start an instance, it will stay on the same host, as no other companies can run instances on your dedicated host, as it's dedicated and not shared like a non-dedicated instance. Dedicated instances will also run on a host that does not have any other companies or customers running instances, but some of your non-dedicated instances can be run on the same host as your dedicated instance. Also, if you stop and start your dedicated instance, it may change physical hosts, but will always run isolated from any other instances from any other companies. So that's one of the big differences, right? So the dedicated instance, if you stop and start it, it can switch hosts. Where a dedicated host, you have a single host, and it never changes. And then if you had physical issues with that host, then there would be an issue, because that's the host that you got. And then a dedicated instance can run with other machines that are your machines, that aren't necessarily dedicated instances. But if you had other EC2 instances running, they could be run on the same host as your dedicated instance. Whereas your dedicated host, if you own you basically own that machine, you could run some of your other instances on that host, but you don't have to. You can isolate it and just have the dedicated instances that you need and use all the power for that host. With the dedicated instances, you're just guaranteed to run on a host with no other companies, but any of your non-dedicated instances may run on the same host as your dedicated instances. You just have a little more control with a dedicated host, and you're unlimited to how many instances you run on your dedicated host, up to the physical limit of the host. So those are two options for especially if you have regulatory restrictions or company policies that require you to isolate your instances from other companies. All right, so we'll cover server storage and pricing in the next video.